So another thing we can do with our generics is actually constrain the possible or the allowed types for a type parameter. So right now our merge function, it's a generic function. It accepts what are supposed to be two objects, but really these are just two things of any type whatsoever. I could do this, merge an object that has, name set to my name, merge that with the number 9. And TypeScript doesn't know to complain, even though I personally don't want that to happen, because if we try and run that code and we console.log it, what's going to happen? What do we end up with printed out? Just an object, right? If I try and spread a number or a Boolean, something that's not an object, into an object, we just end up with an empty object. So I want to make sure we have two actual object types in T and U. Right now, they could be anything. T could be a number, U could be a number. TypeScript won't care. So what we can do is use the extends keyword in here. And I can say type T isn't just any type. It actually has to extend the object type. And U extends object type. So this is saying, they have to be objects essentially, right? They can be any sort of object. We're not saying it has to be of type cat or of type, this object here that has a name set to a string. We're not constraining it in that way. But we are constraining out of all the possible types, string or number or a list. We're telling TypeScript this has to be something that is an object. So we'll see another example of extending and constraining our types. But now, if I try to do that same merge with the number 9, it says argument of type number is not assignable to that parameter of type object. So it has to be an object now. And then in here, I could do something like, num is 9. The pattern of the object doesn't matter. That's not what I'm saying up here. I'm saying it simply has to be some sort of object. I don't care what the type of object is, the shape of the object, it just has to be an object. Let's try one more example, and this time we'll use an interface as a constraint. Instead of saying T extends some built-in type like object, we'll say T extends some interface. So why don't we do something silly, super trivial, we'll write an interface, or this could be a type alias too, but an interface called lengthy. And all that it says is that there has to be some length property that is a number. And then I can write a generic function, something like get length or just print double length. These are all stupid, but let's just go with that. Print double length. And it will accept some T, right? And then we'll say that our element or our input, let's just call it thing, is of type T. We return a number. And then what are we returning? Thing dot length times 2. But we can't do that, right? TypeScript is going to say property length doesn't exist on this totally generic thing T, which is literally any possible type. There's no way that we can know that length exists there. So what we can do is say, well, T extends lengthy. And now TypeScript stops complaining, because the only way we get here is if this T type, whatever that type is, follows the rules laid out by this interface, meaning it has a length property that's a number. So I can call it on, print double length, and then provide a string. This has a length. But if I try and call it on a number, I'll get a complaint. It is not of type lengthy. Now, we could easily rewrite this function without a generic. It's not a great use of a generic. I could just say thing has to be of type lengthy, right? It has to have a length. It's going to complain here because I have a function with the same name. And now it still works. So there's many ways of achieving the same end result, but sometimes there are situations where you need to use a generic and you need that generic to be constrained, like we saw earlier. I just wanted to show you that you don't have to use some built-in type like object or string. You can use an interface or some type alias as well, like lengthy.